Okay, so before we start, the first thing you need to know about significant figures is they have absolutely nothing to do with math, so forget everything you know about decimals. Now, for significant figures, the main thing we have to look at is the word significant. And now, before I actually teach you how to solve significant figure problems, I have to show you why there are sig figs. So, the reason we have sig figs is so that we can show how accurate our tools are at measuring. Like, if you take, for example, a graduated cylinder that looks like this, and a graduated cylinder that looks like this, which one do you think is going to be more accurate? Well, obviously the one with more hash marks is going to be more accurate. So the reason we have significant figures is so it can tell how accurate our tools are. Because a triple beam balance is not going to be anywhere near as accurate as an electric mass thing. So, the first thing you have to know about sig figs is that there are 3 rules about the zeros in significant figures. There's ending zeros, starting zeros, and middle zeros, I like to call them. Now, the way the 3 types of zeros work is that I'll start with middle zeros, because they're the easiest. Whenever a zero is in the middle of 2 actual numbers, like 1 to 9, then that zero will always be a significant figure. So if my number is 109, this is a significant figure. And now, the reason that is because it's just telling us how that is. Although, if my number is 10009, it's still in between 2 zeros, but it's still in between 2 significant figures, or 2 integers, so therefore it actually is still a significant figure. Also, now for ending zeros will not be significant unless there is a decimal point. So therefore, the number 900, these 2 zeros are not significant. But if I made it 900 decimal point, then these 2 zeros are significant. The reason for that is because if our tool is more accurate, then it'll be able to give us a decimal point. And the same rule applies here for adding more zeros on the end. If I go 900.00, that tells me that my instrument can give me to 2 zeros. So therefore, this has 5 significant figures. Even though it's still technically the same number as this has 5 significant figures, this has 1. Now, for the starting zeros, which are the zeros that come when you have a number like 0.003, starting zeros will never be significant. Now, this might confuse some people because what if there's an ending zero like this, 10.002? These numbers will be significant because they're after a significant figure. But if it's just 0.000, until you see an actual integer, those zeros are not significant. So this only has 1 significant figure. This has 5. Now, when you're solving equations, like say you're taking the density of an object. So that's density equals mass over volume. So if you get 2 measurements like mass equals 26.6 grams and volume equals 27 ml, the way that this works is you have to use the number that has less significant figures. So volume has 2 significant figures, so therefore my answer has to have 2 significant figures. So my answer will be 26.6 over 27 mlg, blah blah blah, calculatify it. My answer will have to have 2 significant figures. I'm going to change this to 27.0 just so that I know what the answer is. And now the way I have to write this, it has to have 2 significant figures. So a way I can write 1 with 2 significant figures is go 1.0. And the reason that we have to have the smallest number of significant figures is because our answer cannot be more accurate than the reading we got with the tool. So since the reading we got with the tool is only 27 milliliters, our answer cannot have more than 2 significant figures. Because that'd be like taking a triple beam balance and getting a mass of 1 gram, and then saying that the mass is 0.9999 grams. We just don't know that because our tool wasn't accurate enough. That's about